Hello everyone. If you can see us, if you can hear us, please let us know and set the thumbs up in the YouTube chat. So we will be so happy to see you here today. There is a meetup prepared by DataStax with the help of our great Yelp people and as a part of a Blueprint London virtual event happening actually today. And I have to introduce you our special guests. But before I will not do that as long as I don't see any hello thumbs up in the chat. Let's warm up a little bit. Okay, hey Dennis, thank you. And that's incredible to have you here today. We have Dennis Gosnell. That's a very big pleasure for us to see. So, I'm Alex Voloshev, developer advocate at DataStax, but my role today is very simple. I'm only to introduce you those who really matter today, those who will speak about the things, those who will make their great presentation and showing so many incredible things we are going to see all together. I'm excited to be here today. I hope you are too. So, let me introduce Aysel, Alex, and Benoit from Yelp. And hello, everyone. Say something.
Hey,
hi.
How are you?
Yeah, good. So,
hello.
Yeah, could you please introduce yourselves?
Aysel, you start.
Yep. Hey, everyone. I'm Aysel. I'm a technical recruiter at Yelp, and I'm here to talk about the open positions that we currently have.
Great. And you know what? What really matters in every project, it's always about people. Technologies, great team, even with not the best technologies, can build great products. And like not so great team, even with the best of technologies, may build not so great projects. So here today we speak about great technologies and also Yelp are hiring great people. So I still will have a moment for that. And Alex, who are you and what do you do at Yelp?
Hey folks, my name is Alex. I'm a software engineer at the database reliability engineering team. I've been part of Yelp for about 4 years now. And today I'll be talking about the Stargate at Yelp.
Mm-hmm. Okay, yes, so Stargate is new for most of the visitors of today's talk. So you are going to learn something new, what really extends the possibilities of Apache Cassandra or DataStax Enterprise. Today we speak about Apache Cassandra. And Benoit, who are you and what do you do?
Hey, so I'm Benoit. I'm French. I live in Boston and I work for the DRE team at Yelp, same team as Alex. And today I will be presenting to you how we do schema changes and the lessons we've learned like deploying a new system to handle Cassandra schema changes at Yelp.
That's a really great and very interesting topic. I work as a developer advocate with Apache Cassandra, first of all, and really a lot of people ask, like, how do you manage schema changes? Really a lot. That's every workshop I get this question. So I can't wait. You are going to speak. You are last, definitely not the least today in the list. So please stay till the end. That's definitely something what deserves your attention. So I think we can start, and I'm going to switch to the first part. That's for a few minutes. Aysel will take our attention to show what are the hiring options now today at Yelp. Okay? So give me a moment. We are switching. Good. Aysel, so they're all yours.
I am here to talk about our open positions at Yelp. However, before that, I wanted to introduce myself briefly and just say a little bit about what excites me to work at Yelp. So I'm Aysel, I'm a technical recruiter. I've been helping grow teams within engineering in UK and Germany. I've been at Yelp for over a year now. And there's a few things actually that excite me to work at Yelp. However, I would say if I had to highlight the main two, that would be people and culture. I'm very happy and lucky to be working with amongst intelligent and supportive and kind people that motivate me on a daily basis and help and push me to grow further. And I also really like the culture at Yelp, and one of the things it promotes, which is one of its core values, is playing well with others, treating people with respect, and encouraging collaboration. So that's about me, and here's why why other people want to work at Yelp. So Yelp enables us to fuel professional growth, meaningful opportunities, so people can engage in learning programs and obviously have a rich culture of diversity and inclusion. And with over 14 Yelp groups across the company, there's a place for everyone at Yelp to feel included. So now in terms of hiring, we are hiring for multiple roles, as you can see here. So we're hiring for data backend engineers, site reliability engineers, database reliability engineers, applied scientists and data scientists, machine learning engineers, and engineering managers. These are just some roles amongst others that we have currently. We are hiring in the UK. To also note that we are hiring across all the cities in England. So there is an opportunity to work fully remote from any parts of England. Don't have to necessarily be based in London. If you are based in London, then we do also have an awesome office based in Liverpool Street that we will be going back into. No matter whether you choose to work fully remote or from an office, you will be also part of a dynamic environment and an exciting team, and of course participating in our regular hackathons and offsites virtually at the moment. So I guess get in touch, have a look at our website on the careers page, so yelp.com/careers. You can also email me directly if you have any questions. However, you can go on the careers page, have a look at the roles and apply, and we'll be in touch. And that's all for me.
Great, thank you. So, what's comes next? Next comes Alex, and it comes not alone, but he comes with Stargate. So, if you don't mind, Aysel, I would ask you to switch off your shared screen, and we have to ask Alex to share his, and we are about to start.
Mm-hmm. All right, let me share my screen.
So your camera is on, and now we are waiting for your screen. But don't worry, no pushing. While we are waiting for the screen, how long do you work with Apache Cassandra?
All right.
Yep, your screen is live.
All right. Yeah, I had some technical difficulties, but now I'm back online. Yeah. Thanks for tuning in, folks. So today, in this talk, I'll be sharing with you an ongoing project at Yelp that we started earlier this year, which is one of the highest priority projects at Yelp's infrastructure world this year. And the project aims to mainly replace one of the most critical services at Yelp with an open source project that is called Stargate. And so hopefully by the end of the talk, you'll know a bit more about services at Yelp, certain challenges of integrating an open source project into a mature service-oriented architecture, and possibly a few lessons on replacing the most critical piece of infrastructure at Yelp, and in general, I guess, at service-oriented architecture. And so let me just tell you a few words about myself. So my name is Alex. I'm part of database reliability engineering team, and our team spans three different countries. So we are in London, San Francisco, and in Hamburg. And I'm personally working remotely from Hamburg, remotely to the London part of the team. And what we do, what our team does is we do essentially databases at Yelp. We maintain, improve all the data infrastructure related to databases at Yelp. So let me walk you through what's going to be happening today. So I will tell you a little bit about our setup, about history of Cassandra at Yelp, about our setup. I'll share just a few numbers, few interesting numbers, and then I want to talk a little bit about the Stargate itself, and the motivation behind it, why we chose to go with this open source project, and sort of motivation behind the Stargate. And then I want to devote a bulk of our time to the actual migration progress, sort of walk you through the steps that we did to do the actual migration to the project. And so at the end, there'll be just a few more slides about the future kind of steps and the Q&A. So let's start with just a brief overview of our of Cassandra. For those that are not familiar with this database, it is essentially a distributed wide column NoSQL data store. It is optimized for heavy write load, and it has a very fine-grained ability to tune consistency. And just a few interesting numbers about our setup. So we generally have about 90 billion Cassandra queries per month. So we run our production infrastructure and then generally entire infrastructure on Kubernetes. And sort of like on average, on average load, we have about 60 Cassandra clusters and about 500 Kubernetes pods deployed. And in terms of the clusters that have the highest load, read and write load, our highest read load cluster is sort of on average is about 600,000 requests per second, and our highest write load is about 400,000 requests per second. So this is our production setup. We also have obviously multiple environments with pretty much replicated setup, but obviously fewer instances and kind of like lower load. So let me give you just a bit of history of how we use Cassandra at Yelp. So when we started about 6 or probably about 7 years ago, we had just one big monolith application and just a few services. So when we deployed our Cassandra clusters, every service would try to do the discovery of Cassandra cluster on their own. They used different Cassandra drivers, which with versions that didn't match with each other. So it sort of resulted in a very hectic and a messy situation where the load on our Cassandra clusters was not evenly distributed, and the Cassandra drivers were not properly supported by database reliability team. So generally, it was a very kind of like a hectic situation. And so naturally, the next step was to introduce a proxy service, an internal proxy service called Apollo. So nowadays, hundreds of developers at Yelp access Cassandra clusters through this proxy service. And so the original idea of the service was very simple. We wanted to isolate the complexity of accessing and managing the infrastructure from the future teams. And so you can, what kind of allowed us to go even further is to isolate different instances of the Apollo layer, so that, for example, we could isolate the services that have the biggest business impact on Yelp. So, for example, when a certain instance of Apollo will go down, it doesn't impact the rest of the cluster. And so the kind of like advantages and the regional idea was based on, first is we wanted to isolate this whole complexity of managing infrastructure. And then on the future teams, we wanted to let them iterate on the query code a lot faster. And so I'm referring to future teams, but that is essentially, I'll be talking more about this in a kind of like future, but it's generally I'm referring to any team at Yelp that is working with Cassandra as a client, but they're not concerned about the sort of underlying infrastructure of Cassandra. And so for these teams, we wanted to make it easy to iterate on a query code and make it a lot faster. And on our side, as maintainers of the infrastructure, we wanted to iterate on the infrastructure itself a lot easier and faster. So we wanted to replace, the underlying infrastructure, or bump the Cassandra cluster version, or even replace Cassandra driver. All of this, having a proxy allowed us to do all of these things. But as time has passed and Apollo sort of fulfilled its role as a proxy, it is very successful in its use for about 6 years now, but it sort of ballooned in this mini monolith. And right now in 2021, it serves about 140 different use cases across 40 different clusters. And it hosts about 60,000 lines of other teams' business logic and integration tests. And in addition, about 3,000 unit tests have to be run every time we deploy Apollo, which happens about several times a day. And the service itself scaled to hundreds of instances. So generally, on kind of like developer velocity side, we also noticed that service becomes a liability. So for example, when future teams need to write a simplest possible SQL query to get the review content from reviews table in Cassandra, they would need to do a lot of steps. So they would need to obviously write some Python code, write their client and the logic that actually executes the query. They would also need to write unit and integration tests. They would also need to write Swagger specs to kind of expose the API, and a bunch of config values and fake data to kind of like wrap up the setup. So that is a lot of boilerplate just to work with the simplest possible query to Cassandra. And so it became clear to us that the system needed a replacement. An interesting story. When I joined Yelp for the first time, probably about 4 years ago, I was getting a tour around the office and I saw an engineer was writing this schema on the whiteboard. And this is probably the first time I actually saw Apollo. And it sort of reminded me of my reaction. Ironically, it reminds me of my reaction on my first day when I was thinking, what is even going on? What is this Apollo? And I also found out about Cassandra, that Yelp is using Cassandra on pretty much my first day from this schema on the whiteboard, from this beautiful drawing, So anyway, so when we were considering the requirements for the Cassandra proxy replacement, there's primarily two things that we were looking at. So first is we wanted to take the main advantage of Apollo. That is essentially isolation of complexity of accessing and managing infrastructure for the future teams. But at the same time, we wanted to attack its main shortcoming. We didn't want to have any client business logic exist in the service. It should be actually just a simple, thin layer on top of Cassandra. And kind of further side effects that we wanted to have is obviously we wanted to improve the developer velocity so that engineers don't have to write as much code, as much boilerplate to just run as simple as possible query on Cassandra cluster. And we wanted to also simplify the access to the Cassandra cluster and generally have modernize our technology because Apollo has been in production for about 6 or 7 years now, and it's about time to do the modernization. So this is how we found out about Stargate project. So you can generally think of Stargate as an API for your database. It is really just a layer between your application and the database. And it's implemented and used in production by DataStax, the organizer of this meetup. So let me walk you on going kind of like a little bit deeper into how this actually works is you can think of on a very high level about Cassandra cluster as a set of nodes that are organized in a ring. And so when a request comes in, one of the nodes is selected as coordinator. And its role is basically to manage the entire life cycle of the request. Among other things, it should select the proper replicas or proper nodes that have the copy of the data, query them, gather the reply, and send it back to the client. So Stargate is based on this concept of a coordinator node. And it's sort of very similar to fat client notion. But it generally means when Stargate is deployed, it joins Cassandra cluster as a coordinator node. But the important distinction is it doesn't store any data. And so this allows us to have a very interesting setup. So sort of side effect of this is we could ideally scale up this compute layer, the Stargate, independently of the storage layer. And generally on a very high level, sort of like a high level architecture is it joins the cluster as a coordinator node, but at the same time, it also exposes a set of APIs for the easier access of feature teams. And most notable ones are, REST API and GraphQL API. And we went with GraphQL API, and let me just walk you through the kind of like a few reasons why we chose to go with the GraphQL. So GraphQL API is basically allows us to have a type-safe API, right? It solves an interesting problem, kind of very common problem of over and under fetching of the data. GraphQL allows feature teams to define the exact fields that needs to be returned, sort of kind of solving this problem very naturally. At the same time, it also allows to run multiple queries in one atomic request, sort of like in atomic fashion. For example, when we want to keep multiple views of the same data or we want to update multiple tables at the same time, avoiding the network round trips and saving the latency, obviously. And we also can have custom formatters defined. So for example, we could have custom date formatting, custom text transformation. For example, we could have numbers formatting, all of it done kind of like on the client side. And it would be a lot more harder to achieve with the CRUD interface, with the REST API. And generally, finally, GraphQL is becoming a new standard for API development, and it's used extensively right now at Facebook, Twitter, GitHub, as well as Yelp. We've been using GraphQL for quite some time now, and there's already a lot of feature teams that kind of get used to using GraphQL. And so we assume that the transition to GraphQL-based API is going to be a lot easier for the feature teams. And so let me tell you a little bit about our progress so far. So we kind of like broke down our internal transition from Apollo to Stargate into several steps. So we essentially started with just a simple MVP deployment of one Cassandra node. And then we did a few interesting tweaking to certain aspects of the deployment, right? So we looked at the client libraries, essentially a way of it's a way how services interact with each other in Yelp's ecosystem. So we did a bit of tweaking to GraphQL Playground. I'll share a few interesting tips there. And then finally, we did a few interesting developments on the testing and operability side of things. So before we even start any deployment, we kind of wanted to look at the Stargate and understand what are the limiting factors in setting up this kind of like thin layer. How does the resources scale as we scale our service? Is it stable? Are there any crashes, memory leaks? Are there any resource limitations? And so we did this very basic, simple MVP deployment setup with just a single Stargate node that joined a test Cassandra cluster with 3 separate replicas. It had so we ran 100 threads, and we were trying to keep the load up to 3,000 requests per second on the cluster. And there's a few scenarios, right? So we're keeping the load for 24 hours kind of continuously. And we wanted to test how the Stargate would behave if we would do the rolling restart of Cassandra cluster. And what if we do the restart of the instance itself? And we also looked at the authentication token expiration in the Stargate node itself. So basically, what's going to happen if the authentication token expires? Is it going to start throwing errors, or latency is going to spike up? And so you can see on the graph, kind of like the result of our test is we were gradually increasing the load on a cluster, and we kept it at around 3,000 requests per second for the majority of the day. And in terms of latencies, we kind of feel that the latencies are in a very acceptable range. You can see that the high tail latency spiked a little bit at the end, but we did a bit of JVM tuning to bring these latencies down a little bit. So we kind of reused the Cassandra settings, Cassandra JVM settings there. And so as a result of the deployment, we kind of understood that the memory is generally stable. There are no leaks. The CPU load is increased with the amount of throughput that we have, that we put at the system. As I mentioned, we also did a bit of tuning to the JVM that decreased the high latencies a little bit. And so about the authentication token, we noticed that when it has expired, the latencies spiked massively because the servers just started erroring out. And what we did is we basically disabled authentication token in favor of a more sort of sophisticated authentication strategy, which I will cover a bit later in the sort of future work area. And then at the end, we automated the entire benchmarking setup so that we can run the setup at any given moment, going forward as we do more development to the Stargate, as we do the migration of clients. So let me tell you a little bit about the client libraries. So services at Yelp generally communicate with each other, not through directly managing, HTTP queries and responses. So we use client libraries. And so our current approach is to automatically generate client libraries from Swagger specs. And so this is what we decided to do with the Stargate. We decided to kind of like leverage this mature infrastructure, mature client lib infrastructure at Yelp to also automatically generate the client lib for the Stargate. And our Swagger spec looked something very close to this code. We basically expose a single endpoint where client can give key space that they need to access and the body, the actual GraphQL request. And on the client side, so the client, the feature teams, when they work with Stargate, they work with the service as if it's any other service in Yelp's ecosystem. So what they really need to do is to just import the library, call the endpoint, and pass their query, and get the result back. So very simple. It sort of reminds you of just querying the local package, so you don't even know that the network request goes underneath. And kind of like having utilized this mature infrastructure gave us a few out-of-the-box interesting kind of like properties. So clients have automated service discovery of the Stargate instances. They don't need to directly write down the host and port of the instances. The discovery is done automatically. We were also able to have a very granular control of the request budgets and the propagation of distributed tracing headers so that we could integrate Stargate into our distributed tracing infrastructure. And generally, with the client lib, you have out-of-the-box client-side observability metrics available to you. And so we were able to integrate that in our kind of like metrics dashboards. So in terms of GraphQL Playground, when clients want to iterate on their queries, the easiest and the most sort of widely adopted way of doing this is through a playground. It's essentially a graphical interactive in-browser IDE. So we did. So when you work with the GraphQL Playground, Stargate gives a few interesting things out of the box. You could press on a schema or docs on the right corner, and you can see all the available operations that you can do on a selected key space. You can add the table, drop the table, or run a particular query, a mutation. So like everything that you probably need to construct your query is available right there in the IDE. And we did a few interesting tweaks to kind of like improve the setup. So in order to limit the possibility to run a very damaging and possibly costly queries, we only made Playground available in development environment and disabled that completely in production. And we also disabled the ability to run schema table-related queries. For example, it's not possible to create a table, to create a key space, or destroy key space through Playground on production. And the way we do it is sort of a very interesting topic in itself. And Benoit will share a little more about it in the next topic, in the next talk. And another interesting tweak that we did is when client run their query, the GraphQL query, they usually get the response back in sort of JSON format, right? And we also added the actual SQL query that the original GraphQL query was translated to, so that clients can have visibility into what is actually happening underneath. What is the actual query that is being run by Stargate? So in terms of testing, traditional unit testing is relatively straightforward. From the upstream service point of view, Stargate service is just no different than any other service, Python service in Yelp's ecosystem. So kind of like all the best practices involving, mocking fixtures are applied to our service as well. So generally at Yelp, we use, PyTest and Python mock libraries to do the mocking of our service calls. A more interesting thing is integration testing. And as opposed to just pure unit testing, which is entirely self-contained within a project, working with acceptance testing raises certain challenges just because of the number of real external components that tests rely on. And so in our setup, we use an internal tool at Yelp that replaces Docker Compose that we kind of call, Yelp Compose. And the original idea of the tool is to just simplify the service discovery and making service dependencies a lot easier to handle for the feature teams. Let me just walk you very quickly with a simple example of how can this be done. So when developers start working with Yelp Compose, they really only need to know 4 commands: how to start their playground, how to build, how to start it, how to get a status of their playground, and how to stop it after they're done. And so it's a simple example. Imagine we have a very high-level service business details, and we want to write an integration test kind of like end-to-end. So when we want to actually test end-to-end environment, we need to know all the services, all the downstream services that are being called by the service that we want to test. And it's usually extremely complicated to know the entire request lifecycle. So what we do is we allow each owner of the service to define their own Yelp Compose.yaml file, where they essentially point to a Docker file that shows how to build their service. And when each service has this file exposed, when you run your playground, the Yelp Compose will recursively look through the files, and it will recursively build like the one giant Yelp Compose file and build the environment out of it. So that means that when you want to test your service, you only really need to know first-level dependencies. In our case, it's just user reviews and special offers as examples. So that simplifies a lot on kind of like testing side of things. So there's a few more interesting things that we did to kind of like bootstrap the clients when they work with Stargate. So we created 2 simple files. One is one file that would create a test key space, and another that would create a test table that would populate Stargate on start. So when Yelp Compose starts our service, this is what is happening very roughly. We essentially start the actual Stargate instance. We wait until it's healthy and it's up. And once it's up, we run the queries that we define. So we essentially bootstrap by running, creating a key space, creating a table, so that by the time Yelp Compose environment is up, and when client just starts environment with YCP start, they already have the key space running. They already have the table inside, and all they need to do is to just focus on their business case. They're kind of like testing the actual business logic and not care about any kind of like Cassandra internals. So we hope that will really simplify the process of writing integration tests for the clients. And so on operability side of things, we did a few interesting tweaks here and there. I won't go into much with details of every single point, but generally we did a few interesting things. So we integrated the Stargate in our distributed tracing infrastructure so that clients can have an easier way to have visibility into the timing of the requests, look at the latencies of how long each request to the Stargate takes. Then we also exposed the actual Stargate metrics for the better observability. The actual load, the CPU load, the memory load on the cluster. And since Stargate joins Cassandra cluster and works as coordinator node, it also exposes the standard Cassandra metrics as well. So the very nice side effect is we were able to look at the Cassandra metrics and Stargate metrics sort of in parallel and compare the results. We also did a bit of tweaking to the error logging so that we can integrate with our error dashboards. And we added just a internode TLS setting for a bit of a security. And so in terms of the actual migration of the clients, there's a few important steps that we need that we did to kind of like facilitate this process. So so generally internal migration done in 2 steps. So we started with just a beta step where we work on the steps that I just mentioned, working on the MVP, working on the client libraries, testing operability, and in parallel we were doing initial set of conversations with future teams, where we essentially identified just a few potential good candidates for the test migration. And we were looking at generally the complexity of the cases and the business impact. And by the kind of like when things are ready, when we are done with our milestones, we wanted to do just a simple internal migration of one client. Kind of like select the easiest case, maybe like a simple select statement, and try to migrate this to a GraphQL case. So once we migrate the first client, once we let it marinate in a production for a bit of time, we go into a internal general availability state, where we set a moratorium on the new Apollo client. So no code should be added to the Apollo at that point. And we set a deadline on the migration of the existing Cassandra clients. And the DRE team itself, we wanted to prioritize a very high priority clients that have the complex cases where they have a lot of business logic that exists in Apollo, where the business impact is very high. So, and then in terms of future work, there's a few areas that we wanted to attack that sort of right now are in more of a planning phase. Obviously, we need to spend quite a bit of time on the security and authentication part of things. The only kind of authentication that was available to us by default is just the token, and we disabled that in favor of more role-based, I guess, authentication setup. We also wanted to work on the persistent queries to avoid running to kind of like have more visibility into what are the queries that are being run, and for a few different other reasons. And then we also wanted to make a few improvements to the client library to have the comparison when we want to do the dark launch to our clients. We want to do the comparison between the status quo response and the new response from GraphQL to kind of confirm that we're not doing damaging things, and actually finish the client's migration part. That's pretty much it. Pretty much what I wanted to share with you. Thank you very much for your attention. Thank you very much.
Great, Alex. Thank you so much. That's kind of unique moment. We have 2 Alexes at the screen. Some replication factor on Alex. So before we proceed, and I will read some questions from the chat. I wanted to ask, you said what you have auto discovery for Stargate nodes, and how do you do that? So what's at this side?
Yeah, so let me go. So essentially, Apollo thing is, as I mentioned, is just a proxy service, just a service that exists on top of Cassandra cluster. Let me actually go back to the slide. I think the slide will actually demonstrate it really well.
Yeah, sure.
Okay, hold up. Okay, there you go. So this is what I pretty much mentioned at the very beginning. So when there's no sort of proxy by default, every service that exists in Yelp would try to access a separate Cassandra cluster, and that results in a very sort of messy situation, right? And so what we have right now is Apollo is essentially a Cassandra proxy service. It's a service that lives on top of Cassandra cluster that is deployed separately, and that simplifies a lot of things on our side. And there's a few reasons why we did that. We wanted to isolate the complexity, make it easier to iterate on query code, and make it easy to iterate on infrastructure. So this is pretty much the thing that we're actually replacing.
I see, great. So, question on the YouTube chat from Vinod Sankar. How do you handle large partitions in Cassandra? Also, can you give an estimate on how big is your largest partition in production?
So this, so I cannot really tell out of the box or from the top of my head. It's sort of an interesting question, but it feels a little out of the scope of the talk.
Definitely.
Let me get back to you maybe after the talk. I'll need to double check. It's sort of an interesting question that I don't have an answer from the top of my head.
Yep, I would say from my at least point of view, there is only one proper way to deal with large partitions. Do not create them by proper data modeling. I wouldn't suggest anything better than data modeling indeed. So I'm trying, there were a question about the cluster you were testing, Stargate. A question was, is your cluster multi-data center? But I guess answer is no, because it's an MVP and test cluster.
So our current Cassandra, the actual Cassandra setup, the Cassandra clusters that run on Kubernetes, they are, we have a few data centers. We have two big ones. So yeah. But in the Apollo setup, the sort of like the service that exists on top of it, we actually deployed in two big regions.
Yep.
But the sort of the MVP, the Stargate, is obviously we just deployed an MVP. It's very early to say how the setup is gonna look in the future.
Okay, and finally, I mean, introducing the data API layer like Stargate or Apollo. That's actually a pretty big job, so you are putting a lot of effort into that. My question is, what do you think the biggest benefit for developers developing application, developing your project, and what's the biggest benefit of using these data API for the business you run? Because those points of view are usually a little bit different.
So, well, as I said, there's a few sort of big benefits, right? So there's obviously a benefit on the client side. They can run their there's a sort of like developer velocity improvement, big one, right? So they don't have to write as much boilerplate code. There's a lot of improvement on kind of like beneficial improvements on our side as well, because we don't have to support as much of infrastructure load. So the layer becomes a very thin sort of layer. And that translates well into a business, I guess, business perspective, right? Because if the developer velocity increases, then we're able to ship things faster. We're able to ship things a lot kind of like more reliable in a more reliable way. And on infrastructure side as well. Right now with Apollo, we have an interesting situation when it's sort of like it ballooned to this big size, and when one part of the service goes down, then the blast radius can take a few other services, down with it. And so when we have a Stargate, when we have a thin layer, kind of like more reliable thin layer instead of Apollo, that obviously simplifies a lot of things on our side as an infrastructure team. We can invest more time into other features that are beneficial for the clients, and that kind of like goes back into the loop that clients are able to future teams are able to ship things faster. So I'd say just having this project in itself, it's a lot of effort, but it genuinely translates well into like all sides of the organization, and on the feature teams, on the infrastructure part, and the business itself.
Okay, so two last questions, but already pretty briefly, because we are a little bit out of time and we have to keep some time for Benoit. So first question, Stargate offers not only GraphQL, but also REST API and Document API. What do you think? Yes. Are you going to use them, or those aren't so interesting to you?
That's a good question. We did consider at the very beginning, we kind of like look at the possible options, and we decided to go single-handedly with just GraphQL. REST API is something we did consider, But as of now, GraphQL is sort of the only focus that we have, and we want to make our infrastructure so kind of like support this use case as much as good as possible, I guess.
Okay, and last question. Anyway, no more questions regarding that on YouTube chat. So, Stargate is an open source project, but frankly speaking, I just don't know if Yelp was involved into the direct development of Stargate. So, but my question is not about the past. My question is more about the future. What do you think about the participating in the Stargate as an OSS project?
It's a good question. I think it's more of a business, I guess, related question. But just to tell you a little bit from my experience of the kind of like past few months of working with it, with the repo, we generally kind of like work very closely with the development team. So the development team always is very open to answer any of our questions. We did submit a few kind of like issues that we encountered. We also did submit a few minor improvements to the actual open source project. And internally, we keep the fork of the project, and we try to merge the high upstream changes kind of like regularly. So it's hard to say how the setup is going to look like in the future, but right now it's sort of like we keep the fork, and we from time to time when we discover an issue, we submit the issue to the GitHub, and we try to resolve it if possible ourselves.
Great, thank you so much. That's incredible, and I'm happy to see how this project grows and develops over time. And I guess your experience to share it today will help many more people to give it a try and take a look how useful it could be, how could it increase their developer velocity. And that was Alex Shirokov from Yelp, and we are going to introduce Benoit with the next talk. So Benoit, could you please share your screen, and Alex is going to switch off his. Hi Benoit, could you please turn on the camera? Yeah, perfect. And yes, your screen is live, you are live. And wait a second. Say it again.
1 2 1 2. Can you hear me?
You are live. Okay. Screen live, you live, sound live. Let's start.
Okay, so let's talk about how we do schema changes at Yelp. First of all, the obligatory introduction slide, and since I'm a parent, you get to see a photo of my child. Let's get that out of the way right now. About me, so I've been at Yelp for 8 years. I'm part, just like Alex, I'm part of the DRE team, the NoSQL side of it. I work remote from Boston, and I've been doing so for a couple of years, so before it was cool. And then my latest hobby is that as of this year, I've tapped my own maple trees in my backyard, and I'm boiling my own maple syrup. All right, overview of the talk. I'm going to tell you how we used to do schema changes at Yelp, and why there were what the issues were with the previous system. We changed to a new system, and so I'm going to explain to you how developers submit and apply a schema change. Then I'll give you an overview of how the new system works, and I'll finish with some lessons learned. There are some positives and some negatives. First of all, a little definition. I'm going to use the term pushplan, which is specific to Yelp. A pushplan used to be a text file that contained just a set of written instructions for an engineer that is deploying code, usually to production, to apply before, during, or after deployment. These could be config changes, or most often were schema changes. And so we kept that term, and you'll hear me refer to it throughout this talk. And when you hear pushplan, you can really just swap it with schema changes. Pretty interchangeable. So for preparing for this talk, I looked a little bit at the stats in terms of to try to give you an idea of like how many schema changes we do at Yelp. So over the past 6 months, we do about 15 push plans per month. knowing that a Pushplan could be several different SQL statements. These were written by 35 different developers on many different teams and were applied to 15 different Cassandra clusters, which can exist in 5 or so environments. So we have a development environment, several staging environments, and finally a production environment. So before, all of our schemas for all of our Cassandra clusters were stored in a Git repository. And on each Cassandra node that we owned, we had a process that was running in cron that would periodically verify that the schemas on the cluster actually matched the schemas that were stored in the Git repository. If the schemas did not match, the process tried to make the necessary modifications. And if the process was unable to, it would file a Jira ticket to let us know that, hey, there is a mismatch and that manual action needs to be taken. So there were several challenges with this approach, and a lot of them stem from the principle of least surprise. So this is straight from Wikipedia. The principle of least surprise says people are part of the system. The design should match the user's experience, expectations, and mental models. And as you'll see, the expectations really didn't match, and there were lots of surprises. So first of all, we didn't support auto table statements, which is a pretty big problem in my opinion. The process that ran on the Cassandra nodes could only create tables or create key space, and so anything else would need to be done manually. And nothing would really tell developers that. Yes, it was written in our documentation, but who has time to read the documentation? Also, the second point is that the developers didn't get any feedback if and when their schema changes were applied. So a lot of times we would get like people coming in our Slack channel and asking like, hey, I made a schema change an hour ago and I don't see it yet. Like, is it still going? Like, what's going on? And also the third point is the schema changes would be applied in a random order of environments. So it's really just whichever process is up in the cron tab would pick it up. And so the schema change could be done in production before it was done in the development environment, which is really not a good practice. Like we should do the schema changes in an increasing order of importance. So starting your dev and then stage and then production. And also we suffered from a lack of context. So this is an actual commit that I found in this Git repository. I removed the name of the developer because I didn't want to publicly shame them, but this is really not a very good Git commit message, and it doesn't give any context about what the change that they're making, like what purpose does it serve. It doesn't point to any like external resource that would enable us in 1 to several years to go back and figure out like what this was about. And talking about the review process, we would only rely on human review. So each schema change would be reviewed by us DRE members, hopefully. And we were the ones saying like, hey, your SQL statement is probably not syntactically correct and may fail. Plus, there was no actual mandatory review from the DRE team, so some schema changes could possibly go to production without us looking at them. And so overall, it was more work for us because we had to explain these surprises over and over again. We had to go debug problematic schema changes, not necessarily knowing where they were tried to be applied first. And we had to do a lot of manual schema changes because auto table statements were not supported. So we needed a better system. And luckily for us, at that time, we joined forces with what was called the database team, so the MySQL team, and they had a system in place that they used to do schema changes. And we evaluated writing a whole new system to handle schema changes for Cassandra. But ultimately, we decided to modify the existing MySQL system to make it a system that can handle schema changes for both MySQL and Cassandra. So before I explain to you how it works, I'm going to go step by step and explain to you how a developer would go and start a schema change. So first of all, the developer would clone this Git repository, which is called Pushplan. And on every one of our development box, there is this utility called Pushplan, which is used now to handle schema changes. So a few interesting things to note. So the developer would start by creating a Pushplan. They give the database type. Interestingly, the interesting thing is that there is a mandatory Jira ticket field here. So what this means is that each schema change has a mandatory ticket attached. So we can always go back and read about the context behind the schema change. And then you give it a cluster, a key space, and optionally a table. And the result of this is that it creates in the right path, it creates an empty SQL file where the developer can now write their SQL. So let's go write that SQL. We create a very simple table, meetup.attendance, and it has 2 columns, ID and name. So now let's transform this SQL file into a Pushplan. So the developer now uses the Pushplan generate YAML command, passes it that SQL file, and so we have a couple of validation errors. The first one is that we have an unknown data type. str is not a valid data type. Second one is I forgot to specify a primary key. Interesting thing to note here, we added a message that contains a URL to our internal documentation, which goes into more details about why it failed, and in some cases will give details about how people should resolve these validation errors. So turns out I'm a very bad Cassandra developer, so let's fix this schema and add a primary key and change str to varchar. Let's try again. And now the generate YAML command succeeds, and what it does is it replaces this SQL file with a YAML file. And let's go look at the content of that YAML file. So at the bottom, there are 2 main sections, metadata and the actual statement section. So the metadata, let's go through the fields. So we have a unique Pushplan ID, so we can refer to any schema change by this unique ID. We have the requester. Run by is a field that we can set manually to manual. And what this does is it would prevent the Pushplan to be applied automatically. In some very rare cases, we still want to apply some Pushplans manually. A timestamp. Version is a field that enables us to make breaking validation changes, meaning that if we write a new validator that would make validation break for some previously existing schema changes, we would bump the default version to +1. What that means is the higher the version number, the more strict the validation will be. And then the developer will open a pull request, get now a mandatory ship it from one of us in DRE. And finally, once they have that positive review, then they can merge their comment. And then everything works automatically. The Pushplan is going to, the schema change is going to be applied in increasing order of importance. So first in our dev environment, then in our stages environment, and then finally in production. And for each of these environments, the developer will be pinged on Slack with the result of the Pushplan. So as you can see from this example, this garbage Pushplan, which actually is that is a MySQL Pushplan, but it doesn't really matter. It looks exactly the same for Cassandra. That Pushplan failed in the dev environment. The developer also has a couple of options to go check the result of the Pushplan. So we have the Pushplan status command, which gives brief information about like the status of a specific Pushplan. In this case, we can see that it succeeded in dev and stage and it ended up failing in prod. And we have the Pushplan history command that gives a little bit more detail about how a Pushplan was run. But more interestingly, it allows us to list all the push plans that have been applied on a specific cluster. We can also specify an environment. So that's if we're trying to answer the question of like what change that could have caused this thing 6 months ago, the Pushplan history command would be a good tool to use to try to see if there were any schema changes that happened during that time. So let's go into a little bit of a system overview. So we rely on a Git repository, which contains all the MySQL and Cassandra push plans. The Pushplan generator Python package is installed on all of our development boxes. It has the Pushplan command, so Pushplan create, Pushplan generate YAML, and so on. And it does the the validation of Cassandra and MySQL Pushplans. We have the Pushplan execution service that is in charge of running workers that will apply schema changes, again, for both Cassandra and MySQL. And the brains of the operation is the AWS step function state machine. So this really controls the execution of the schema change, makes it so that we run from one environment to the next. And all the statuses of push plans are stored in the backend MySQL database. So each push plan will be in that database with the status and the time that they were run and the environment. So going from left to right, a push plan is started either manually via the DRE tools command or automatically when the commit is merged into master. And then what that does is it's essentially starts the state machine for the dev environment. The push plan execution workers will pick up the push plan and attempt to apply it. If it doesn't succeed, then it fails, and it will fail fast, meaning other environments will not even be attempted. If it's successful in dev, then we'll go into we'll start another state machine for the next environment until we finish in the production environment. And if it's successful, then the push plan is going to be marked as successful. So going a little bit deeper in the push plan execution worker logic, there are a few steps, a few things that the worker will check before even running the SQL statement. First of all, we're able to ignore some environments within the push plan. I didn't show that in the YAML, but you can add some YAML to say like, hey, I'd like to ignore the dev environment. If that's the case, then the worker will just skip the push plan and I'll continue to the next environment. We'll also check if the cluster for this push plan actually exists in this environment. So not all clusters exist in all environments. So we do check that first. And then finally, has a push plan with a similar push plan ID already been completed in that environment? This is really important because this ensures that we can only run a push plan a single time per environment. Like we don't want to have a case where we would run the same push plan more than once in an environment. And so once the worker finds out that, yes, indeed, they should be running the push plan, you'll mark the push plan as enqueued. So this means like write that into the MySQL database of the Pushplan execution service. It will acquire a zookeeper log for this environment and cluster pair. What this does for us is that it ensures that we only do a single schema change per cluster at a time. We decided that we didn't want to have more than one schema change happen at the same time. Once the Zookeeper lock is acquired, we'll mark the Pushplan as started in this environment, and we'll ping the Pushplan author on Slack. We'll say, hey, we're starting the schema change in this environment. The worker will connect to Cassandra and apply the SQL statement. And if it's successful, it will mark the Pushplan as completed, again, writing that to the MySQL database, and it'll ping the author on Slack to tell them that their schema change was successful. If the schema change was not successful, the two last steps would be exactly the same, but replace completed with failed. So let's talk a little bit about the automated validation of a SQL statement that we do. There are several advantages to this. First of all, we don't solely rely on manual testing of SQL statements. So we always recommend developers that they try their SQL statements like on a test cluster. But we can't rely on that. Like we can't rely that everybody would do that. And so we can still catch a lot of errors with this automated validation. And then developers get fast feedback on syntactically wrong SQL. So before they would, in the previous system, they would open a pull request and they'd wait a few hours, days to get feedback from us that, hey, actually, this is not valid SQL. This is not a valid SQL statement. Nowadays, they get feedback as soon as they try to generate that Pushplan YAML file. And we're also able to enforce best practices that we've established here in DRE. So it's not just to say, hey, your SQL statement is syntactically correct. We also ensure that they're doing the right thing. And that's a really important thing for us. So how does the automated validation work? We wrote a fairly simple large parser that supports only the SQL schema modifying statements. And we parse the SQL, and once it's parsed, for each of our validation rule, we'll inspect the tree, the parsed tree, and we'll verify that it matches our validation, like it's okay with regard to our validation rules. So a few examples of automated validation rules that we have. So we have some simple things like what you saw, like one and only one primary key per table, that all the table options are valid and of the valid type. And then the two last ones are things that we've decided to do. It's not necessarily that the SQL statement is not valid, it's just that we've decided that this would not be okay. So while we had a mix of Cassandra 2 and Cassandra 3 clusters, it's not the case anymore, but it used to be, we decided to say, hey, let's prevent people from altering column types, even if this could have been valid in a Cassandra 2 cluster. We wanted developers to be educated that this would not be possible anymore. And the second example is not adding more than 20 columns at a time. We've had an incident about a year ago where a schema change was adding hundreds of columns to a Cassandra table. And the effect that this had was that it brought the cluster down to its knees, and like the metadata that was added was just way too much, and the performance of the cluster was really badly impacted. And so when we wrote the postmortem for this incident, we decided that we would add a validation rule that makes it so that a developer is not able to add more than 20 columns at a time to a table. And interestingly enough, a couple of months ago, a developer was trying to do just that, and they reached out to us, and so we talked to them about this change, and the result was that we worked, because of that validation failure that they had, they came to us and we worked with them to actually make this change possible, and we split their SQL statements into many different SQL statements, and we ran them manually to ensure that the performance of the cluster remained decent throughout this operation. And it's really easy to add new validation rules. It's just a simple Python method that takes the parsed tree and just checks that some things in the tree are as they should. So what are the lessons learned after running the system in production for about 6 months now? So a couple of challenges. From the point of view of a developer, a new schema change it's a little bit more involved. Before they just had to modify a single file in a Git repository and things would be changed. Now there's a little bit more red tape. But ultimately, we think that this is for the best, and it allows us to have a safer Cassandra infrastructure, and also like developers get fast feedback. Also, we're storing in that Pushplan Git repository, we're storing only diffs of the schemas, so it's only the actual the SQL is what changed. We still have a need to store the full schemas in a separate repository, specifically for integration testing for Apollo. And so developers need to actually change the schemas into different places, which is not ideal, but that may go away once this target project is completed. And positives, there are two sides of positives. So first of all, the schema changes reviews are much easier for the DRE team. Automatic validation does most of the work. We don't have to hunt like silly SQL mistakes. We can, when we review a schema change, we can spend more time to actually think whether the schema change is what needs to be modified and not about like the nitty-gritty of it. It's now possible for us to enforce Cassandra best practices. So it's not only like, is your SQL statement valid? It's also like, are you doing the best thing you can? And developers know how to get the status of the schema change. They don't need to come to us anymore to ask like, hey, what is happening with our schema change? I don't see anything. I guess. Okay, I'm missing a couple of slides here. I don't know what's happening. Okay. Yep. That's all right. We'll just wing it. And the last big positive for us is that we have mandatory context gathering for each of the schema change. So because we enforce that there is a Jira ticket attached to each schema change, it means that a few years after a schema change happened, we still can easily find documentation around that schema change, why it was made and why it was done in a certain way. And that's really vital for us. Great. So I had a hiring slide because we wanted to let you know again that Yelp is hiring. We are hiring both for the DRE NoSQL team and for a lot of different other teams. So if you're interested in a career at Yelp, come visit careers.yelp.com, or you can reach out to Isel. You can find her email address in the beginning of this presentation. So, and just as a conclusion, we do a lot of schema changes. We have a lot of clusters. Maybe you work for a small company and you don't have a need for such like a big project to manage your schema changes. But like we think there are two important takeaways for you. The first one is gathering feedback. We think it's really vital. So if you don't have a process in place to like attach a schema change with some context, try to put that in place. It will maybe save your skin in a few years when you have a bad problem with a previous schema change. And the second one is automated validation. It may not be necessary for a lot of people, but we found that for us, it really helped us save a lot of time for developers as well as for us, like Cassandra administrators, and it makes applying a schema change a lot safer and easier. Thank you for your time. I will now take a few questions if there are some questions.
Yep. So there is, first of all, this is great. Thank you from Dr. Dennis Gosnow, which is really great to see. I have one question on YouTube chat, which doesn't directly relates to that topic you told, but I guess will be interesting to all of our listeners. Are you using only one database, Cassandra, at Yelp? I know what answer is no, but yeah, we would like to hear.
So if we're talking about database types, we have at Yelp, we have mostly support for MySQL database, as well as Cassandra database. And if you consider Elasticsearch database, then we also have a lot of Elasticsearch clusters. And these are the three main database types that we support at Yelp. If we're talking about database clusters for Cassandra, no, we don't have a single. We don't run a single Cassandra instance at Yelp. We run dozens of them. I don't actually. It's several dozens. I don't actually know the number. Plus, each of these clusters runs independently in several environments. So all in all, like we run probably more than 100 Cassandra clusters at Yelp.
Talking about your presentation, some years ago, many years ago, I read a book by Robert Glass, one very cool software engineer with like long, many dozens of year experience in this field. And there was a phrase in his book, what it would be great to have the ability to link every change set, every change in our code into the task what we are doing. So bad we don't have this ability. And I was like, oh yeah, it would be indeed great to have this ability to link them. And I'm like, stop, but we do have already. I realized that what book was written before the tools like Git were introduced. And now we have this ability, and you go even further, you are linking the change sets to the schemas of your database to a particular task you are executing, and you are automating validation to do that. I'm a big fan of Automagic and the things you automate like that, how it helps the developers and business, and that's incredible to see people taking care of that so seriously. That's a really incredible talk, and that's really incredible job you are doing there. Like I see we have many dozens of people watching this meetup live, and very warm feedback. And now we see what with the attention what Yelp puts to their code and how do they work with the database, with schema changes, migrations. That's maybe a really good place to work, so you may have to contact either. And I think I'm switching back to the main view, and if you have any more questions, that would be great to get you people asking them right now, because we are going to stop. So ask now or stay quiet forever. Kidding, ask questions later. You guys will be able to find us on LinkedIn, I think. So give me a moment, Alex. It's weird. Give me a moment. Okay, so I see no more questions, only thank you, this is great on the YouTube chat. So I think that's we are done, and enough for today.
Well, thanks for attending. It was a blast, and yeah, come talk to our HR, to our tech recruiting folks if you're interested to come see for yourself what we're doing here at Yelp.
Yep, And I don't know about our attendees, but I'm definitely to contact you, not because of a hiring questions, sorry, but more, I want you to speak more often at Cassandra Global Meetups, at DataStax developers on YouTube, because you guys have incredible experience with Apache Cassandra and community over the world wants you to share it. That's for sure.
Right.
Okay, so that was Blueprint London virtual event, Yelp engineers speaking at the meetup organized with the support of the DataStax developers. And thank you everyone for attending us. And I think we are done for today. So thank you and see you next time. Have a great week.